Right, guys, so this next lesson, following our proportional relationships, is non-proportional, which essentially is going to mean that it is not proportional. So we're talking about relationships that are not proportional, or the opposite of a proportional relationship. So as we go through these notes, I want you guys to see and think back to our notes that we took on proportional relationships and see how they compare. So in this situation right here, we're looking at a relationship between two quantities in a non-proportional. They're non-proportional if the two quantities is not constant. So if the value between the two quantities or the relationship between the two quantities is not constant. So in a proportional relationship, it was constant. In a not proportional or non-proportional, it's not constant. Right? So a graph of a non-proportional relationship will not pass through the origin. Okay. It will still be a straight line, yes. So I want you guys to know that it still will be a straight line. We're looking at linear equations, linear relationships in this unit, which line. So we're still going to be looking at a straight line, but we are not going to have it pass through the origin, okay? So making sure we have that kind of in the back of our head. Instead of crossing through the origin, the graph will cross on the x-axis at a point that is known as the, let me rephrase that. It will cross the y-axis at a point that is known as the y-intercept. So it has to cross at the y-intercept somewhere. So if this is our y-axis, it's got to cross somewhere along this y-axis, but not at 0, 0. So it could cross here, it could cross here. Okay, it's going to cross somewhere. It could even cross this direction, right? So when we're looking at these, those are the types of things that we look at. So we are asked what should be true about the x value of an ordered pair for a y-intercept. That's something I want you guys to think in the back of your head, and we're going to discover that as we go through this lesson. So just making sure we understand the relationship that exists there, and we'll discover that through the process. So I don't want to quite get that to you yet. So in her search for a gym, okay, so now we're going to look at the situation again. Hillary's found a different gym, and this location charges $10 as a one-time sign-up fee, and then she charges $20 each month. So we're going to use that information to complete the table and then to complete the graph. So let's make sure we pull out. We got a $10 as a one-time sign-up fee, so this only happens one time, and then it's $20 each month. So if I go for 0 months, so $20 for 0 months, I want to start, I have to pay that $10 sign-up fee. Okay, so my value here is going to be 10. All right. Here, if I go for my first month and then I add in that original $10 that I paid, then the expense that I've now incurred is $30. All right, we can see this pattern. If I go to the gym for 2 months, and I add in that original $10 fee, now I'm looking at $50 as my cost. And then it would continue as we go through this. And we can see that this would end up being 70, and then we continue so forth. So 20 times 4 would be 80, plus 10 would be $90, and then 20 times 4 x here, plus 10 would end up equaling our y value. So we're saying that every time we take 20 and multiply whatever our x is and add 10, it equals our y. So this again is our x, and this again is our y. Okay, so can we identify a slope or rate of change? Absolutely we can. Okay, so again, our slope and our rate of change of how this is happening, it's essentially going to be this number or this coefficient that we have coming before the x value each and every single time. So if we looked at this right here, we would say 20x plus 10 equals y. Okay, it's this coefficient, but we can prove that if we wanted to. We could we could say we have x values and y values, okay, and we could work our way through that. But let's go ahead and do this. Let's see. We did 10 minus 0 over, I see my mistake. Okay, I need to do y over y and then x over x. So let me write out what I'm doing. I have 0, 10, and then I have 130. Okay, so I would do 30 minus 10 over 1 minus 0 is equal to 20 over 1, which is equal to 20. So writing these out will help you from making the silly mistakes that I was making. Okay, so that right there is how we can identify the slope or the rate of change, but we can also recognize that it's the coefficient that is in front of the x. All right, so what is the value of the y-intercept? So where would this end up crossing on my y-intercept every single time? So what was the value of my y-intercept when this was 0? It was 10. Okay, so my y-intercept each and every single time was what happened after the process of my coefficient and the x. So it's a positive 10. It was minus 10, it'd be a negative 10, right? So that's where it's going to cross the intercept, and you'll see that, the y-intercept, when we get over here. So is this table proportional? The answer is no, it's not proportional because there is not a ratio, or the ratio from y to x is not constant. It changes. So my ratio, or how I get from y to x, is not the same every time. From 50 to 2, here it was 25. Okay, from 30 to 1, my ratio would have been 30. So I don't have the same. I can't get from here to here by following the same one number each time. All right, so making sure we recognize that. I know that when I look at my equation because I have this plus 10. Okay, so now we're going to go and we are going to use these coordinates to graph. So again, we're going to give our graph a title. We're going to say cost of gym. And we're going to say that this is our number of months, that this right here represents the cost or the expense that we're incurring to go to this gym. And then we're going to use these points right here. So 0, 10, I'm going to go to 0, and then I'm going to go up 10. So this is where I'm going to start. Then I'm going to go 1 to 30, 2 to 50, 3 to 70, 4 to 90, and then so forth. So if I connect my lines, I can see that it does not go through the origin. So I want you to pay attention to that. So the point that it is crossing this x-axis is at this 10. So what is the slope or the rate of change shown on the graph? So I could figure that out by doing my rise over my run is a way that I could go about and figure that out. So we can compare our points when we go through this process, or recognize we have our rise over our run between 2 points. Again, if we calculate that out, so for example, if I was doing here, my rise is going to be 1, 2, 3, 4, and then I go over 2. So my rise over my 1 was 4 over 2, and that's going to equal 20. So remember, you can calculate rise over run. Okay, last time I showed you by comparing the 2 points, but remember, you can do that counting rise over run, and that's totally acceptable. You could do that for any of them. You could do 1, 2, so that's 20, 10, 20 over 1. Okay, so we can see the relationship that exists there. All right, so rise over run. What is the value of the y-intercept? So where does it intercept the y-axis at? And this is the value. It intercepts it at 10. And it asks if it is proportional. And the answer is no, because it does not go through the origin. Okay? So it does not pass through the origin. Instead, it passes through our y-axis at 0, 10. It passes it at the 10, so not at the 0. Okay, so that's how we are going to identify that. So now it's asking us to write an equation that would represent the situation that we were talking about. And we already kind of did that. We said that y was equaling, so our slope, which is 20x plus the $10 origination fee. So our equation that would represent this here is the 20x, which this is the slope, plus the $10 origination fee. So do you see the slope in the equation? We're going to say yes. Okay. It's 20. Again, it is the number or coefficient in front of the x. All right, so we can see that. It says, do you see the y-intercept in the equation? The answer is yes. Okay, if so, where do we see it? And we can say it is the y-intercept is 10, and we know it's a positive 10, and we can recognize the relationship that exists there. And it's that 10 that's added to the end. So what conclusion can we make about non-proportional relationships? We can make the conclusion that the slope is the coefficient in front of the x, okay, and the y-intercept is the value added, right? So we're going to be looking at the value that's added or subtracted. So if it ends up being, it could actually start below the 0, but it's the value that's being added or subtracted, okay? All right, so non-proportional equations will be written in the form of, and this is what we call slope intercept form, y equals mx plus b, okay? B represents where it crosses the y-axis at. So where m is the slope and b is the y-intercept. All right, so if we just look at this equation here really quickly, we can identify that this slope is the -4. My y-intercept is what I add or subtract, so it's going to be a positive 9. And is this proportional? My answer is no, because I have the plus 9. Okay, this one right here, my slope is the coefficient that comes before the x, so it's 3/4. My y-intercept, or b, is this number right here. It is a -8. Okay, so include that subtraction there as identifying that it's -8 where it's going to cross that y-axis. And is this proportional? My answer is no. It is not proportional because it's going to cross the y-axis at a -8 down this direction. Okay, all right. Now here my slope is 1.25. My y-intercept, there is nothing added or subtracted on here, so I know that my y-intercept is a 0. And is it proportional? Yes, it is, because it intercepts the y-axis at 0, 0, therefore it goes through the origin. Okay, so let's look at a real world example, and then we're going to be pretty much done for the day. Caroline is going to a state fair with a group of friends. It cost her $12 for admission, and once she's inside the fair, she buys tickets for 75 cents each in order to play games, purchase food, or go on rides. So we need to look at this situation. She pays $12 just to get in. So that's a flat fee of $12. And then she has to pay 75 cents each. So the tickets for 75 cents each. Okay, so we're going to write an equation to represent the relationship between the cost, which is going to be y, is going to equal the amount of tickets that she buys. So she's going to buy some tickets for 75 cents a piece, and she's going to pay $12 just to get in. So this right here is our equation that's going to represent that situation. So just looking at the equation now, can we identify the slope? The answer is yes. It's the 75.75. What is my y-intercept? It is 12. Okay, so describe what a graph of this relationship would look like. So where is the line going to start? That's one way that we can describe it. So it's going to start at 0, 12, because it's going to cross at 0, 12 on the y-axis. So if I visualize what's happening, the line would be straight. I would have a straight line. And I could say that it's fair that it would have a slope of 0.75.